And these are the 3.2 notes, domain and range, page 1. It's going to feel like a lot of redundancy in these notes, so make sure you pick and choose the pieces that you need. So example 1. Oh, I'm sorry, that's rude. What do you remember about domain and range? So our domain is always all possible x values, our inputs. So all possible x values, or our inputs, and our range then is all possible y values, or our outputs. Okay. We're going to talk about different ways to write. We've got inequality notation to start. We're going to use interval notation. WebWork likes the interval notation. I think it's a little easier sometimes than the inequalities, at least when computer programs were starting. We want to make sure we can graph this on the number line and describe what we've got going on. So let's start. First off, this is how I remember it. I can draw a little fishy with the mouth open, and that's always eating the bigger number. So I'm going to write it as a description first. This is x is greater than a. Oops, out of the box. Which means if I've got some number a on the number line, x is strictly greater than. So we've got an open circle here. We are not including a. And we are looking for all the numbers that would be bigger than a. In interval notation, smallest number always starts at the left, so we're going from a to infinity. Parentheses means we do not include those endpoints. So the infinity is always going to have a parenthesis, and our a here has a parenthesis because it is not included in the interval. X has got to be strictly greater than a, does not include a. So the next one down, I'm going to start over here with the description again. X is less than a. So again, wherever my a is, I do not include it, so it's an open circle. We are looking for numbers less than a, so to the left. Again, smaller bound on the left, so negative infinity to a, again, parentheses on both ends because we cannot include those. Infinity always has a parenthesis, can never be included because it's not a number, it's a concept. It means to grow without bound, either in the positive or negative direction. So the next one down, x is greater than or equal to a. So here's our a, fairly consistent with the other ones. Because x can be equal a, we've got a solid dot there, and we're looking for all the numbers bigger than a. So again, a to infinity, a parenthesis on the infinity. We've got a square bracket on the a because this time we can include the a. So x is less than or equal to a. Oops, less than. Stick a right there. Again, x can equal a, so we've got a solid dot there that's included. Negative infinity to a, parenthesis on the negative infinity, square bracket on the a. Next one, a is less than x is less than b. So x is between a and b. But is not equal to a or b. And so A has got to go to the left because that's less than x. B has got to go to the right. We've got open circles at both because neither of those are included in this interval. And so our interval goes from A to B, does not include either. Okay. So the next one, A is less than or equal to x is less than B. X is between A and B. A inclusive. So we're including A in this interval, but not B. So we've got a solid dot at A to show that X could be A. Goes all the way up to B, but does not include B. Again, our interval is from A to B, parenthesis at B, square bracket at A. And so the next one down, X is between A and B. I'm going to write this one a little different, and can equal B. Same interval, A to B, closed circle at B because we can equal B, open circle at A showing that we can go down as far as A, but we don't include A, square bracket on the B, parenthesis on the A, and our last one, X is between A and B. A and B, and can be A or B. So from A to B, inclusive, square bracket on A, square bracket on B, and there is our interval notation that goes with the corresponding inequalities. So the domain and range of a function as a set of values. So here we have a set of ordered pairs. Again, our domain is all of our possible x's. I'm going to go ahead and try to write those in numerical order. Actually, I think they're given that way. So our domain is the set. That's what the curly brackets means. We've got a set, -5, 0, 5, 10, and 15. Close that curly bracket. Range. It's going to be the set of all our y values. I am going to go ahead and try to put those in numerical order. So -12, -8, -4, 0, and 4. Page 1, domain and range.